Hello everyone, in this video we are going to discuss about the nomenclature of organic compounds. You know that everyone needs name, like that all the compounds also needs name. Earlier the scientists give the name based on their properties and their origin, like the acid found in citrus fruits is called as citric acid, and the acid found in red ants is called as formic acid. Like that they used to give the names to the organic compounds based on their origin and the certain properties. But the later there are many organic compounds are developed, so that it is little difficult to give the names like this. So that the UPAC means IUPAC, that is International Union of Pure and Applied Chemistry, has made some rules to give the name to the organic compounds. So in this video we are going to discuss about the UPAC nomenclature, means International Union of Pure and Applied Chemistry has made some rules to give the name to organic compounds. So that in this video we are going to discuss about the nomenclature of organic compounds. We shall learn the UPAC nomenclature in a very simple way. Here you can see that there are 5 parts in the UPAC nomenclature: primary prefix, secondary prefix, word root, primary suffix, and secondary suffix. Word root is very important. It is a middle part and important part. So the words which comes before the word root are called as prefix, and the words or substituents which comes after the word root, this is the main thing, and the words which or the substituents which comes after the word root are called as suffix. Okay, there are 3 parts: prefix, word root, and suffix. Here we have distinguished the prefix as primary prefix and secondary prefix. The word root is same, this is the main part, and suffix as primary suffix and the secondary suffix. Okay, so word root is very important. Word root and suffix, you can find the word root and suffix in every molecules. Every organic molecule should contain the word root and suffix. You depends upon the molecule, you may get the secondary suffix, or the you may get or you may not get the secondary suffix, primary suffix, and secondary prefix. Okay, but you should get the word root and primary suffix in each and every organic molecules. Then we shall learn what is the role of these prefix and word root, all those things. Okay, I have told you that word root and primary suffix are very important. Word root is main thing in the organic molecule. It shows the number of carbon atoms in the main chain. Okay, the word root shows the number of carbon atoms in the main chain. It shows the it gives the details about the main chain. Okay, so that if your compound containing 1 carbon atoms, you can give the word root as myth. Myth means there is a presence of only 1 carbon atom. Only 1 carbon atom is there in the molecule, so that you have to give the word root as myth. If there are 2 carbon atoms are present, then we have to give the ETH, that is eth. Like that, if you are having the compound containing 3 carbon atoms, then that is prop. If it is 4, it is but. Pent for 5, hex, hept, oct, non, and dec for the compound containing 10 carbon atoms. Okay, so word root shows this is the main part of the nomenclature or the name. It gives the information about the number of carbon atoms present in the main chain of the organic compound. If it is containing 1 carbon atom, then you have to give the word root as myth. It is 2, then eth, 3 atoms, then propane, prop, 4 but, 5 pent, 6 hex, hept, oct for 8, non for 9, and dec for 10. Okay, then what about the primary suffix? It gives the primary suffix gives the information about whether these carbon atoms are connected by single bonds or the double bonds. Okay, it gives information about whether these word root, the carbon atoms which are there in the word root, are connected by a single bond or the double bond. If the carbon atoms, if there in the molecule there is no double bond, only there is a single bond, means it shows that you have to give the suffix as ane. It is a alkane family. Okay, if you have a double bond in your compound, then you have to give the ene as a suffix. Means there is a double bond in the compound. If there is a triple bond is there, then you have to give it as yne. Okay, the primary suffix gives the information about the saturation, means whether the compound is containing single bonds or is there any double bond or is there any triple bond. Like that, you have to give the suffix. Okay, these two are very important. And second, we shall discuss about second suffix because it is not applied for all the compounds. If it is only for if saturated monocyclic compound are there, the second suffix should be cyclo. It is cyclo. Secondary prefix is cyclo. It is comes only when you have the saturated monocyclic compounds. Okay, if you have saturated monocyclic, this is the saturated monocyclic compound. This is also saturated monocyclic compound. Cyclohexane, cyclopentane, means like that. We shall discuss the nomenclature of these compounds in the later sessions. So when you have the saturated monocyclic compound, this is also saturated monocyclic. There is no aromatic compound. This aromatic compound, you know what is the meaning of monocyclic and saturated. Saturated means there is no double bonds. So that in this type of molecules, you have to give the prefix as cyclo. So when you have this type of compounds, then only you have to give the secondary prefix as cyclo. Okay, we understood the word root means how many carbon atoms, if there are how many carbon atoms are there in the main chain, then you have to give the word root. And if there is a single bond, you have to give ane as a suffix, en as suffix when you have the double bond, yne as a suffix when you have the triple bond. Then if you have the substituents attached to this word root, okay, if you have attached with the substituents like CS3, okay, when you have attached these groups with this main chain, then these should be come to primary prefix, means these should be named before the word root. Okay, this if you attach CS3 group with this word root, means this is the main chain. If these alkyl groups attached to this main chain, then the name of this should be come before this word root. Okay, and I have also, if you have attached this halogen groups with this main chain, then these should be named before this word root. And nitro and alkoxy groups also named before this word root. These groups are always the prefix. Okay, then if you are attached with CS3 group with the main chain, then the prefix should be methyl. The prefix should be methyl when you have attached with CS3 group. When you have C2H5, then the prefix should be ethyl. If you have attached the C3H8, prefix should be propyl or propyl, then butyl. Okay, these are the prefixes comes before or given before the word roots. Then what about EF means halogen, fluorine. The prefix for fluorine is fluoro. For chloro is for chlorine, bromo is for bromine, iodo is for iodine. If you are attached NO2 group with the main chain, then nitro should be your prefix, and this is alkoxy prefix. Okay, these are the prefixes. When these groups attached to main chain, then this should be comes given, name of these should be given before the word root. Okay, if you are attached, these are always the prefixes. Okay, you have to consider these groups before the word root. Okay, then what about the role of the secondary suffix? Okay, if you are attached with these functional group, then these are always comes under this after the word root. Okay, when we have attached the COH group with the main chain, then suffix should be oic acid. This is sulfonic acid. Okay, if you have SO3H, then this is sulfonic acid. This is ester group, ester functional group. If you have the ester functional group in your main chain, then the suffix should be O8. Okay, then you have acid chloride in your compound, then we have to give the suffix as oil halide. You can take this for this like this. Okay, this is oil chloride. This is general formula, that is oil halide. If you have COCl, then you have to use oil chloride. If you here you have amide. When you have the amide, the suffix should be amide. This is a cyano group, then the suffix should be nitrile. This is aldehyde functional group, the suffix is Al, means all, Al. This is carbonyl group, the suffix is ONE. OH is the alcoholic functional group, OL is your suffix. Amine group is there, so that the suffix should be amine. Here we have double bond and triple bond. These are comes under the this one. Here you have to give the ENE and YNE. Here I have mentioned as in the primary suffix. Okay. When you have the functional groups, you have to give the suffix as, for COH group you have to give the oic acid, SO3H sulfonic acid, ester group, that is COOR O8, COX suffix is oil halide, COCl oil chloride. It is. If you have amide group, then the suffix should be amide. CN group is there nitrile. CHO Al is the aldehyde group, so the suffix is Al. CO, this is ketone group, the suffix should be ONE. This is alcoholic group, suffix is OL, all. NH2 amine group, suffix is amine. CO double bond and triple bond, here I have mentioned it is ene and ine. Okay, this is about the this one functional group. When we have the functional group in our compound, if we have two or more functional group in your compound, okay, if you have only one out of these, then that will come after the word root, that is second, that come will under the secondary suffix. There is no problem. When you have this one or two or three functional group in the same compound, then we have to choose the main functional group and the secondary functional group. So here I have given the table, this list in the order of preference. This will be the first order, first preference, second, third, fourth, like this, so that these will be the higher order functional groups. So when you have COH group and the cyano group, this should be your main functional group. Then CN should be come as a prefix. So when you have the two or more functional groups, then you have to choose the functional group, choose the main functional group. Okay, main functional group, then main functional group will be your suffix, and the other functional group which is not main functional group, those come for as a prefix. Okay, then if you have the cyno group, if you have the CN group attached with the other higher preferred functional group, then this should be come as a primary prefix. And if you have NH2, then also with the other higher preferred functional group, then that will come as a prefix. OH and OCS3 also comes to the this one prefix. Okay, when these act as a prefix, then prefix these should be changes. Okay, like this. See here, when CN is in the prefix, when CN is in the suffix, then this should be named as a nitrile. But when CN is in the prefix, when it is attached with the other higher prepared functional group, then CN comes as a prefix, then CN will be given as cyno. Okay, then if NH2 attached with higher prepared functional group and this is not main functional group, then this amine name should come before the word root as a primary prefix, then this is amino. Okay, OH, when OH comes, when this is the only functional group, then it should be given as suffix, that is OL. But when this OH is attached with the other functional group, attached to the compound which is having other functional group, that is main functional group, then this OH comes under the primary prefix, then it is given as hydroxy. Okay, hydroxy is the prefix for OH. And OCS3 or OR, for OR we have to take the alkoxy. Here I have written alkoxy, same, and this for methoxy. Methoxy is for OCS3. Okay, hope you understood this chart. This chart is very important. This chart is very important. Here you can see there are 5 parts. There are only 3 parts: prefix, word root, and suffix. Prefix we have distinguished it in primary prefix and secondary prefix. Word root is main thing, and suffix we have distinguished into primary suffix and secondary suffix. Word root is very important because this shows the number of carbon atoms in the main chain. Okay, and suffix shows the whether these main chain containing double bond or not, double or triple bond or not. Okay, so that word root, it gives the information number of carbon atoms in the main chain. If it is 1, then you have to give the name as meth. If it is 2 carbon atoms, then you have to give the eth. For 3 it is prop, but, pent, hex, hept, oct, non, and dec for 10 carbon atoms. Okay, if the compound containing single bonds, then you have to give the suffix as ane. So the name of this compound will be like, if it is carbon containing C only one if the compound containing only 1 carbon atoms, then it will be methane. If it is 2 carbon atoms, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Like this, the naming nomenclature will be there. If there is a double bond, then you have to give the ene. Okay, it is like if only one carbon atom, there will not be a double bond. For 2 carbon, it will be like ethene, propene, butene, pentene, hexene, heptene, like that. Okay, there also we have to give the numbering where there is a double bond, like that. We shall discuss in the later hours. Okay, and then yn is for if there is a triple bond, then you have to give the suffix as ine. Okay, propine, butane, pentine, like that. Okay, these 2 are main things, means all the compounds containing this word root and suffix. If you have the compound like if you have the saturated monocyclic compounds like these, then only you have to give the secondary prefix as cyclo. Means cyclo, here you can see that this is a cyclo group, so that you have to give the secondary prefix as cyclo. Then here you can find the 6 carbon atoms are there, so that it is hex. Then there is no double bond, so that you have to choose ANE, so that cyclo is the second, cyclo hex ane. Here you can find the 5 carbon atoms. This is cyclo pent ane. Like this you have to give the name. Okay, then if you have attached the these are the main groups. If you have attached some groups to this main chain, then you have to give name to those substituent also. Those come under the prefix, that is primary prefix, so that you have to give the name to those groups before the word root. If you attach a CH3 group with this main group, you have to give the methyl, ethyl, like for CH2H5, propyl, butyl, like this. If you have halogens attached to this the main chain, then you have to give the fluoro, chloro, bromo, and iodo for iodine. If you attach nitro and OH, OR for alkoxy. These comes as a prefix. Okay, we should not consider these groups. We should not consider these groups for prefix. These are always the prefix. Okay, then if you attach to some functional groups, okay, the functional group will come under the secondary suffix. COH, SO3H, like this, the functional groups comes under secondary prefix, and you have to give the secondary prefix as oic acid for COH, sulfonic acid for SO3H, O8 for COOR, this is ester group, COX, oil halide for COX, amide, nitrile, aldehyde AL, carbonyl group is ON, ON means ketone group, ON, alcoholic groups all, amine, NH2 for amine, ene and ine. When you have 2 or more functional group in your compound, then it is a little difficult, so that we have to give the preference, so that this will be higher prepared, the preference will be in the decreasing order. Okay, so in that case you have to give the principal you have to check out for principal functional groups. Principal functional group means main functional group, and out of 2 or more we have to find out the principal functional groups, main functional groups, that should be your suffix. Okay, and the other should be go to prefix. Means here we have COH, which is having higher prepared, then also we have the OH. This is less prepared than this one, because this is principal functional group and this is other functional group which is not preferred over this COH, so that this OH should name before the word root as a prefix. See here, CN, cyno. If you are naming the groups as under prefix, you have to give the cyno for CN, amino for NH2, hydroxy for OH, methoxy for OCH3. Like this we can give the names. Okay, by taking examples we shall discuss the nomenclature of this. So first example is CH3, CH2, CH2, CH3. Here you can see that there is no substituents, so there is no primary prefix, there is no cyclic ring, so there is no secondary prefix. Word root and suffix is must, and there is no functional group substituent, so that there is no secondary suffix. Here you can see that for word root, first you have to write the word root. The chain 1, 2, 3, 4. There are 4 carbon atoms, so that for 4 carbon atoms it is but. Okay, 1, 2, 3, 4. So that the word root is but, and the primary suffix is must. Primary suffix, there is no double bond in the compound, so that there is only ANE. Okay, so the name of this compound is butane. Okay, it is word root and this is primary suffix, so the name is butane. Look at the second carbon atom, second compound. Here they have given like this, but there is no substituents. It is not substituent, it is a in the chain only. It is a main chain. 1 2 3 4 5 6 7. There are 7 carbon atoms. There is no substituents, so there is no primary prefix, no secondary prefix, and no secondary suffix. Only word root and suffix. So count the number of carbon atoms. 1 2 3 4 5 6 7. For 7 means it is hept. 7 carbon atoms, so that the name is, the word root is hept. So this is alkane chain. There is no double bond and triple bond, hence it is ANE, hence the name is heptane. Okay, third one is, here also there is no substituents. It is a main chain. Okay, it is a chain, there is no substituents, hence count the number of carbon atoms. 1 2 3 4 5 6. 6 means it is hex. Hex is a word root. There is no double bond, hence it is the sub N, hence the name is hexane. Okay, like this you have to give the name to the compounds where there is no substituents or primary prefix and secondary suffix. Okay, just it containing word root and suffix. Okay, look at the fourth example. Here you can see that you have one substituent. Here you have one substituent, so that you may, here you are going to get the primary prefix. Okay, but first thing in naming this type of compounds is you have to select the parent chain. How you can select the parent chain? You can select the parent chain, that means main chain. This can also be the parent chain, this can also be the chain, and this can also be the chain, but you have to select the parent chain. You have to identify the longest carbon chain in the molecule. That will be your parent chain or root chain. Here you can see that this chain containing 1 2 3 4 5 6 carbon atoms, and this chain containing 1 2 3 4 carbon atoms. Here you can see that 1 2 3 4 5 6 7. Here is 7 carbon atoms. This chain containing 6 carbon atoms. This chain containing 4 carbon atoms. Which is the longest chain? That will be your parent chain. This will be your longest chain. Correct? So that this will be your longest chain, and this will be your substituent. This will be your longest chain or parent chain. This will be your substituents. Okay. Then the second thing is you have to give the number to each and carbon atoms, so that you can identify where this substituent is attached. You can give the number from this side 1 2 3 4 5 6 7, and also you can give the number 1 2 3 4 5 6 7. Okay, from both the sides you can give the number, but which is correct? The rule is branched carbon atoms should get the lowest possible number. Okay, this branched carbon atom should get the lowest possible number. From this side, when you give the number from this side, this substituent is going to get the number, means it is going to get the number 5. But when you give the number from this side 1 2 3, it is going to get the number 3, this substituent, so that this is correct. No, the branched carbon atoms should get the lowest possible number. When you give the number from this side, you are going to get the give the number 3 to this carbon, branched carbon, so that this is correct. Okay. Now shall give the number. The identification is over and numbering is over. Now we can give the number, name, word root. First select the word root. You have already selected the longest chain, so that the longest chain containing 7. Okay, that is word root is hept. Correct. There is no double bond and triple bond, so that your suffix, primary suffix will be alkane, that is ANE. Correct. So it is word root. It is word root, and this is suffix primary suffix. There is no functional group, so there is no substituents. Methyl and alkyl groups are always the primary prefixes. Okay, so that you have to use the primary prefix. This should be the primary prefix. So it is attached to third carbon atom, so that it is 3-methyl heptane. This is your primary prefix. So there is no secondary prefix because there is no cyclic ring. It is primary prefix, word root, and primary suffix. So the name of this molecule is 3-methyl heptane. Okay, this is the name of this compound. 3-methyl is your primary prefix. Okay, methyl group is attached to third carbon atom, so that is primary prefix. There is 7 carbon atoms in the main chain, so that it is hept. There is no double and triple bond. It is alkane type of molecule, hence it is ANE, that is primary suffix. So this is the name of the fourth example. Got it? Okay. And the fifth one, here you can see that here also first thing is you have to select the parent chain. This will be your parent chain containing 1, 2, 3, 4, 5 carbon atoms, and 1, 2, 3, 4, 5, 6. This will be your parent. This can be your parent chain because it's containing 6 carbon atoms, and this can be your parent chain 1, 2, 3, 4. Okay, so there are 3 possibilities to select the parent chain, but the rule is you have to select the parent chain. The parent chain should containing the should be the longest chain, means it should contain the higher carbon atoms. Okay, so out of these 3, this should be your parent chain. Means here this will not be your substituent, this will be your substituent. Okay, should not confuse. Okay, this should be your parent chain and this should be your substituent. Okay, then you have to give the number. When you give, there are again 2 possibilities. You have to give the number from this side, and also you have to give the number from this side. When you give the number from this side, 1, 2, 3, 4, 5, 6. Okay, the substituent is going to get, substituent carbon atom going to get the number 3. When you give the number from this side, 1, 2, 3, this is 4, this is 5, this is 6. Here when you give the number from this side, the substituent is going to get the number 4. But what is the rule? The branched carbon atom should get the lowest possible number. When you give the number from this side, the branched carbon is going to get the number 3. So that this is correct. Okay, so write the word root. Word root is hex. Word root is hex because there are 6 carbon atoms. There is no double bond, hence the alkane type of molecule. Primary suffix will be ANE. Okay, and then primary prefix will be 1, 2, 3. 3 at third carbon atom you have the substituent methyl group, so that it is 3-methyl hexane. It is your primary prefix, word root, and it is primary suffix. So the name of the molecule will be 3-methyl hexane. Okay, this is the name of this compound. Okay, and the fourth one, here again you have to start with identification of longest chain. There are 3 possibilities, 1, 2, and 3. Check the number of carbon atoms, 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. 1, 2, 3, 4, 5, 6. 6 carbon atoms. Here it is 7, it is 6, and count the number of carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So which parent chain you have to select? Which should be your parent chain? This should be the parent chain because it is containing the higher carbon atoms, higher number of carbon atoms, so that it is containing 6. 1 2 3 4 5 6. This should not be the parent chain. 1 2 3 4 5 6 7. This should not be the parent chain. This should be your parent chain, and this will be your substituent. Correct? Okay. So identification of parent chain is, you have identified the parent chain. Now you have to give the number to the carbon atom so that the substituent should get the lowest number. When you give the number from this side, 1 2 3 4, you are going to get the fourth carbon atom. You are going to get the substituent at fourth carbon atom. When you give the number from this side, 1 2 3 4 5, it is going to get the number 5. But if it is correct, the substituent carbon atom should get the lowest number, so that this numbering is correct. 1 2 3 4 5 6 7 8. Okay, now give the name. 8 carbon atoms, so the word root is oct. It is AN because there is no double and triple bond. It is alkane type of molecule. Then what about the primary prefix? Primary prefix should be fourth carbon atom. You have 4-ethyl octane. Okay, 1 2 3 4-ethyl octane. Okay, this is the name of this compound. Okay, then move to the next example. Here you can see that there are two substituents are there. Here you have one methyl group, here we have one ethyl group. Okay, first select the parent chain. Okay, here directly we shall select the parent chain. 1 2 3 4 5 6 7 8 9. When you give the name number, when you count the number of carbon atoms, it is going to give 9 carbon atoms in this chain. And here 1 2 3 4 5 6, it is not possible. 1 2 3 4 5 6 7 8, it is also not possible. This will be your parent chain. This will be your parent chain. These two are your substituents. These two are the substituents. Okay, then give the number. Here when you have the two substituents, you have to give the number. We all know that numbering, you should get the numbering should get the branched carbon atom should get the lowest possible number. Okay, when you give the number from this side, 1 2 3 4 5 6 7 8 9, the branched carbon atoms going to get the number 2 and 6. When you give the number from this side, 1 2 3 4 5 6 7 8 and 9, so that number will be 4 and 8. Which is the lowest number? The rule says that branched carbon atoms should get the lowest possible number, so that this is the lowest possible number, so that this will be your numbering system. This is the highest possible number, so that this is not the numbering system. Okay, so that you have to give the number from this side. This will be your correct numbering. Okay, then so first we shall assign the substituents. At second portion we have 2 methyl. These will be your primary prefixes. Okay, 2 methyl. Here you have 6 ethyl. Okay, so that you have two substituents. At second portion you have methyl, at sixth portion you have ethyl. Okay, this is not the possible. Okay, then write the look at the parent chain and write the word root. There are 9 carbon atoms in the parent chain, so that it will be non-N because it is alkane type molecule. Non-N. This is word root and the primary suffix. And there are here we have two prefixes. One is 2 methyl and another one is 6 ethyl. Correct? Which is correct? Here we have to give the first preference should be listed in the alphabetical order. When you have the different alkyl groups, you have to first write the which comes the in the alphabetical order. Okay, here you can see that here you have methyl and ethyl, which will come the first in the alphabetical order. Ethyl will be the first, then you get the methyl, so that name will be 6 ethyl 2 methyl. Okay, yeah, when you have two possibilities, you have to give the you have to write the name in the alphabetical order of the first letter of this word. Okay, so ethyl, E comes first, then the methyl, M. So that you have to select the 6 irrespective of numbering. You have to look for this alphabetical order of this first letter of this word. E and M, you have to look for E and M. E comes first, then M comes, so that you have to select this 6 ethyl first, then write the 2 methyl, and as it is, this is word root and suffix. Okay, this will be your name of this molecule, 6 ethyl 2 methyl non-N. Okay, this is the name of this compound. Okay, look at the 8th example. First, select the parent chain 1 2 3 4 5 6 7 7. This chain contains 7. 1 2 3 4 5, it is not possible. 1 2 3 4 5 6 7, this is also containing 7, so that here we can select this as a parent chain. Okay, so numbering system, in the numbering system, the number should be given, the branched carbon term should get the lowest possible number. When you give the number from this side, 1 2 3 4 4 and 5, but when you give the number from this side, it is 3 and 4. Okay, so that the 3 and 4, you have to give the number 1 2 3 4 5 6 7. So this is correct order of giving the numbering to this carbon terms. When you give the number from this side, it is going to get 1 2 3 4 and 5, but when you give the number from this side, it is 3 and 4, so that this is the correct way of giving the number to this carbon term. First, write the substituents. 3 ethyl, okay, and 4, it is 4 methyl. Okay, these are the substituents. First, write the word root, 7 carbon atoms, so that it is hept. There is no double and triple bond, it is alkane type of molecule, hence it is heptane. Here you have ethyl and methyl. As we have discussed in the earlier example, E comes first, then M, so that we have to write the 3 ethyl first. 3 ethyl 4 methyl heptane, so that the name will be 3 ethyl 4 methyl heptane. Okay, this is the name of this compound. 3 ethyl 4 methyl heptane. Okay, 9th example. Again, the selection of parent chain 1 2 3 4 5. 5 carbon is the longest chain. 1 2 3 4 5. This is also 5. This is also 5. This is also 5. So that you will select this as a parent chain. 1 2 3 4 5. 5 is a parent chain or root chain. Okay, while giving the numbering, we can give the 1 to this carbon, 1 2 3 4 5. Here you can see that this carbon is containing 2 methyl groups. Okay, so while giving the number, you can, when you give the number from this side, this is going to get the 2 3 4. Here you can see that 4th carbon atom containing 2 methyl groups, so that you have to write it in a 2 times. 1 2 3. 2 is containing 2 methyl groups. 1 2 3 4. 4th carbon also containing 2 methyl groups, so that is 4 4. When you give the number from this side, second carbon atom containing 1 methyl, and also the second carbon containing second methyl group, and it is 4. Which is the lowest possible number? Branched carbon atom should get the lowest possible number, so that this is not the lowest, this will be the lowest numbering, so that you have to give the number to this carbon 1, second, this is 3rd, this is 4th, and this is 5th. Okay, Here we have the two methyl groups in the carbon, so that you are writing it two times. It is 2 2. Okay, 2 3 4 5. First write the substituents. It is also methyl. It is 4 methyl. Means for the fourth, at the fourth carbon terms you have one methyl groups. Here look at the second carbon terms, 2. Here we have two methyl groups, so that when you have the two methyl groups, you have to use di. Di is for, you have to use the prefix as di when you have the two same substituents. Which position you have 2? You have used 2 dimethyl. But here also you have methyl, here also you have two methyls, so that 2 dimethyl. For this carbon you have 2 dimethyl. For the fourth carbon you have one methyl. Okay, first we will write the word root. Word root will be pent. Word root is pent, an alkane type of molecule, pentane. Word root and suffix is, there is no problem. The at position 4 there is one methyl, so that the name will be 2 2 4. There are 3 methyls, so that it is trimethyl pentane. Okay, next look at the next problem. Here you can see that first select the word root chain. This is the longest chain. Numbering will be start either from this side, from this side. When you start from this side, you are going to get 3. There are 2 methyl groups at 4th position, 4 4 4. Okay, when you start from this side, 2 3 4, that will be 4 4 and 5. 1 2 3 4 5. So that at 4th position 4 4, and 5th position there is one ethyl group. When you start from this side, at 3rd position there is a one ethyl group, and 4th position there is a 2 methyl group. So that the lowest possible number is, this is the correct lowest possible number, so that we have to give the number from this side. 1 2 3 4 5 6 7. Okay, then write the word root. Word root is 7 hept. 7 for 7 carbon atom, it is hept. So alkane type of compound, so that heptane. And just write the prefix. There is no secondary suffix, only the primary prefix. Okay, at 3rd position you have ethyl, and 4th position you have 4 4. 2 methyl groups are, so that is 4 4 dimethyl. Okay, see here, one primary prefix is 3 ethyl, and that is 4 4 dimethyl. Okay, which one we have to write in first? We have to look for the, we have to write in a alphabetical order. Okay, just CE comes first, then M. We should not consider this D for while writing these in the alphabetical order. Okay, we have to look only for this E and M, so that E first comes first, so that the name will be 3 ethyl, 4 4 dimethyl heptane. Okay, 3 ethyl 4 4 dimethyl heptane is the IUPAC name for this compound. Okay, look at the 11th problem. 1 2 3 4 5 6 7. 7, the main. See, both are same. These both are same compounds. Okay, both are same compound, so that the name will be 3 ethyl. 1 2 3. This is 3rd carbon atom, 4 fifth, sixth and seventh, so that this will be 3 ethyl happen 4,4 dimethyl. There are 7 carbon atoms in the main chain, so that there is a hept is word root, a and a is suffix, so that the name will be 7,3-ethyl 4,4 dimethyl heptane. Okay, in the 12th problem, this is the word root 1, 2, 3, 4, 5, 6, 7, 8. Okay, containing 8 carbons in the chain, main chain. Okay, but the problem is when you give the number from this side, this is going to get the number 3 and this is going to get the number 5, 6. So the substituents are at 3rd and 6th carbon atoms. Okay, similarly when you give the number from this side, 1, 2, 3, 4, 5, 6, here also you are getting the methyl is at 3rd position and ethyl is at 6th position, 6th carbon atom. Okay, then which one we have to select? Okay, from here we have to give the number. When you give the number from this side, this is going to get the 3 and this is going to get 6. When you give the number from this side, you are going to get this is also going to get the 3 and this is also 6. So when you give the number from both the sides, you are going to get the same numbers from both the sides, but you have to select this is also you have to select in the alphabetical order. So this substituent is ethyl, correct? This is methyl. When you give the number from this side, it is going to get the number 3 and this is going to get the number 6. But when you give the number from this side, it is going to get the 3 and it is going to get the 6. Okay, so ethyl we have to select in the alphabetical order. Ethyl comes first in the alphabet, then methyl, so that this should get the lowest possible number. Okay, in the case of when the substituents, both the substituents means if you give the number from both the sides, so the numbering system getting the same, numbering system is same, 3 6 3 6. We have to give the number to the ethyl group 3 and methyl group 6, then methyl 3 and ethyl 6, so that you have to give the number from this side, so that the ethyl substituent get the lowest possible number, because E comes first in the alphabetical order than M. Okay, so that this is wrong. We should not give the number 6 to ethyl and 3 to methyl. 3 is ethyl and 6 is methyl. Okay, this is correct, 0. Then write the word root. 8 is okay, octane. This octane is a suffix, word root and this one. So and primary prefix is 3-ethyl 6-methyl octane. The name will be 3-ethyl 6-methyl octane, correct? So here at 3rd position you have ethyl group, at 6th position you have methyl groups, and the main chain you have 8 carbon atoms and there is no double and triple bond, hence it is ANE 3-ethyl 6-ethyl 6-methyl octane. Okay, then this is 13th problem. Okay, see when you give the number from this side, first you have to select the main chain. First select the main chain. When you select this chain, 1 2 3 4 5 6 7 8 9 10, it is 10 member 10 carbon chain. When you give the number from this side, check this also comes in the chain 1 2 3 4 5 6 7 8 9. So this is not the main chain, but select this check for this chain 1 2 3 4 5 6 7 8 9 10. Okay, when you want to select this chain, this is also having 10 carbon atoms and this main chain also having 10 carbon atoms. Okay, and the other this is not the containing 10, and this is not also containing 10, so that either this has to be your main chain or this has to be your main chain. Okay, but which will be your main chain? The branch, this is also, you can select this as also branch, you can select this as also branch, or this also can be your branch. Okay, when you want this has to be in the main chain, this will be your branch, or when you want to take this in the main chain, this will be your branch. Okay, but which has to be take in the main chain, okay, or principal chain. So the part of the substituents, or this branch which containing the more substituents. Okay, here it's containing only one substituent. Look at this part. Okay, this carbon is common for both, so neglect this branch containing one substituent, but this branch containing two substituents. Okay, this is not the branch, this is the main chain, because we have counted this in the main chain, 1 2 3 4 like that, so that this is in the main chain. This branch containing two substituents, but this branch containing only one substituent, so that this will be your branch or substituent. Okay, and this will be your main chain, so that give the number from this side. Okay, this will be your main chain. Okay, then give the number from to this main chain. We have to either we can give from this side or from this side, but here we are going to get the lowest possible, we have to going to give the lowest possible number to the branched group, so that we have to start with this 1 2 3 4 5 6 7 8 9 and 10. Okay, then it is 3, just it is a branch, 3 3 dimethyl it is. Okay, it is 3 3 dimethyl. Okay, then this one, the branch one is attached to 5, this we have to consider as a substituent. How to write this number? This is a longest, this is a more complex branch or more complex substituent, so that we have to give the number from this carbon atom from here to where it is attached to this main chain. This carbon is attached to main chain, this is the main chain, this carbon is attached to main chain, so that we have to give the number to this carbon atom, not from this side. Okay, here we should not count this, check this substituents. There is no matter, we have to give the number to this carbon atom to which from which it is attached to this main chain. 1 2 3 4. Okay, then word root, there is no problem, 10 carbon atoms, it is word root is dec, suffix is -ane, so the word root is decane. Okay, first you have to write the substituent, this substituent first. Okay, this substituent. Okay, here you have written the this substituent, you have to write the substituent. It is, this branch is attached to 5th carbon atom, so that this will be 5. Okay, it is attached to 5, so that it will be in the outside. Okay, write the name for the substituents. 1 2, it is 2 ethyl. Okay, there are 4 carbon atoms, so that this will be butane, right? But when it is attached, it will be butyl. This will be B branch. Neglect this 5 now. The name of this is, there are 4 carbon atoms in main chain, 1 2 3 4. Ethyl group is attached to the second carbon atom, so that it is 2 ethyl butyl. 2 ethyl, the name will be 2 ethyl butane. Correct? This 2 ethyl butane is the name for this group. But when this is attached to this main chain, you have to write the carbon atom to which it is attached. It is attached to fifth carbon atom. So at fifth carbon atom, you have attached the 2-ethyl. It is not will be butane. It will be butyl. When it is substituent, you have to remove the ANE and you have to add YL. Okay. So these are the two substituents, and this is a word root and this is suffix. Okay, then which one we have to write first? This is E comes first, so that the name will be 5-2-ethyl butyl 3,3 dimethyl decane. Okay, look at the name. Okay, first we have selected the word root. This will be your word root because there are two options, this one and this one, but you have to select the branch which is more branched. You have to select the substituent which is more branched as the word root. So this will be your word root, this will be your substituent. Okay, there are 10 carbon atoms, so the word root will be dec. There is no double and triple bond, hence the suffix is ane. So decane is the word root and suffix. Okay, there are two substituents. Here we have two substituents. At third position, third carbon atom, there are 3,3 dimethyl, and this substituent is complex, so that you have to give the IUPAC name to this branch. You have to give the number 1 to this carbon atom where the branch is started. So this is one carbon, second, third and fourth carbon atoms. So give the number to this carbon. This is 2-ethyl butane is the name for this compound. But this branch is attached to fifth carbon atom of the main chain, so that the fifth carbon atom 2-ethyl butane will be removed. An is removed because it is attached to the main chain, hence it is YL will be added by removing the AN. So the branches are 2, 5 in bracket 2-ethyl butyl and 3,3 dimethyl, but E comes first, so that we have to write this first. 5-2-ethyl butyl 3,3 dimethyl decane is the name for this compound. Okay. Next problem. Select the word root. When you select this word root, the main branch, this containing 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms. This containing 9 carbon atoms. Straight chain 1, 2, 3, 4, 5, 6, 7, 8. It will not be the main chain. 1, 2, 3, 4, 5, 6, 7, 8. So that this will not be a main chain. So this will be your substituent. This will be your substituent because this is containing 9 carbon atoms. This, when you consider this the main chain, this is containing 8 carbon atoms, so that this will be your substituent and this will be your main chain. Okay, give the name to this substituent. 1, 2, 3. It is at second position you have 2 di 1, 2, 3. It is 1, 2, 3 dimethyl. Okay, 2,2-dimethyl. It is propane. Okay, the name of this compound is 1, 2, 3 2,2-dimethyl propane. But when this is attached to the main chain, so that this will be AN will be removed and propyl will be added. Okay, write the word root. Word root is containing main chain containing 9 carbon atoms, so that is non. Secondary suffix, primary suffix an, non will be the word root and suffix. So the name is will be, this branch is attached to, okay, give the number 1, 2, 3, 4, 5, 6, 7, 8, 9. When you give the number from this side also, it is going to get the fifth carbon atom. it is going to give the 5, number 5 to this carbon atom, so that there is no problem. Either you can give the from this side or from this side, it is going to get the number 5. Okay, this branch is attached to 5th carbon atom, so that you have to give the number 5 2 dimethyl propyl nonane. Okay, at 5th carbon atom this substituent is attached, and in the main chain we look at the 15th problem. Here count number of carbon atoms: 1 2 3 4 5 6 carbon atoms, so that word root will be hex. There is no double and triple bond, hence the primary prefix will be ane. Look at the structure here. The rule says secondary prefix cyclo will be for the cyclic compounds. Okay, you can see the rule. Word root for carbon compounds, number of carbon atoms. Primary prefix is for alkane. See here, secondary prefix is for saturated monocyclic compounds, for cyclo compounds. So cyclo is the secondary prefix. Here in this example, the cyclic compound structure, cyclic structure, so that cyclo is the secondary prefix, hence the name is cyclohexane. Okay, this is count the number of carbon atoms: 2 3 4 5. 5 means pent, hence it is cyclic structure, cyclopentane. Okay, then the next example, 17. Here there are 2 substituents attached to this cyclohexane. This is 6-membered ring. There are 6 carbon atoms in the ring, so that this cyclohexane, there are 2 substituents. One is methyl and another one is propyl. Propyl means 1 2 3, hence it is propyl. So which one will get the first number 1? Here you have to give the number to the carbon atoms. So to this carbon gets the number 1, this carbon 2, this carbon gets the 3 number, carbon 3. Okay, because this is methyl group attached to this carbon, and to this carbon it is propyl, means it is propane, 1 2 3 propane, and it's attached. Here we have removed ane and we have added yl. It is a propyl group attached at 3rd carbon atom. Look at these two. M comes first in the alphabets, then P, hence this group gets the number 1. This carbon gets the number 1, this carbon gets the number 3. Okay, this depends upon these alphabets, this P and M. Okay, so the number is, these will be the prefixes, and word root is hexane. Word root is hex. Primary suffix will be ane. Substituents are 1 methyl and 3 propyl. Okay, this is 1 methyl and 3 propyl, hence the name will be 1 methyl. Okay, 1 methyl and 3 propyl. Okay, these are substituents. These will be the primary prefixes. This is primary prefix. This is word root, and this is primary suffix. Then this is the cyclic structure, hence here we have to add the cyclo as a secondary prefix, hence the total number is 1 methyl 3 propyl cyclohexane. Okay, 1 methyl 3 propyl cyclohexane is the name for this compound. Okay, then this is also same, but here we have 2 methyl groups, here we have 1 ethyl group. Okay, in this type of compound, numbering will be, okay, this is methyl group are attached to this carbon atom. Here there are two methyl groups, hence it is dimethyl group. It is ethyl group. Okay, there are two carbon atoms, hence it is ethyl group. Okay, this is cyclohexane. There is no question for the word root and the suffix. See here, numbering, whether we have to give the number from this or this. As we have discussed in this example, you have to consider M and P, which is the which comes first in the this one alphabets, and because of that we have given number 1 to this next to this. But here also the ethyl comes first, then methyl. According to this, if we have given this to 1, 2 and 3, but there are 3 methyl groups, hence this has to give 3 3. So numbering will be 1 ethyl and 3 3 methyl. Okay, this is wrong, so that we have to give the number to this 1, 2 and 3. This will be 1 1 3, which is the lowest order, 3 1 3 3 or 1 1 3. This will be the correct than this one. So that in this type of molecules we have to consider the lowest possible number. This will be the lowest possible number than this one, hence this will be 1, hence this will be 1 1 dimethyl substituent for this, and this is 3 ethyl. Correct? These are two substituents, and we have cyclohexane. Cyclo is the secondary prefix, word root and primary suffix. Then here there are two substituents, ethyl and 1 1 dimethyl, which you have to write in the first order to write these two substituents is ethyl comes first, then methyl, hence it is 3 ethyl 1 1 dimethyl. Okay, the correct name for this compound is 3 ethyl 1 1 dimethyl cyclohexane. Okay, this example is also same as this one, the earlier one. This is cyclohexane, but here we have double bond, carbon double bond here. So cyclo is the secondary prefix. There are 6 carbon atoms, hence hex, number of carbon atoms. Here you can see that there is a double bond in this compound, hence it is not ANE. There is no double bond, hence it is ANE. Here we have double bond, hence it is alkene type of molecules, hence it is ENE. So the name will be cyclohexene. Okay, then this is count the number of carbon atoms, 1 2. It is Br is attached to this one, it is ethane type of molecule, hence it is, this will be the halogens are always the prefixes, always comes in the prefixes, not in the suffix side. These are comes before the word root, hence it is name is bromoethane. Name of this molecule is bromoethane. Okay. Okay, look at this example. Here to this carbon atom we have to give the number 1 and 2. Okay, here 2 chlorines are attached to carbon number 1, hence it di 1 1 dichloro. These are substituents. What about the word root? Word root is eth, because there are 2 carbon atoms, there is no double bond, hence it is ANE. 1 1 dichloroethane. If it is attached to this carbon atoms, it will be 1 2 dichloro. If it is attached, if these two are attached to only to the carbon number 1, hence it is 1 1 dichloroethane. If this chlorine is attached to this carbon atom, this will be Cl CH2 CH Cl. like that. In that CH2Cl, in that molecule you have to give like 1,2 dichloroethane. Here it is both the chlorines are attached to only one carbon atom, and hence it is 1,1 dichloroethane. Okay, here the functional group should get the lowest possible number. Look at this molecule, this is containing only one functional group. Okay, hence we have to give the number 1, 2, 3 and 4. Okay, there are 4 carbon atoms in the ring, hence it is butane. But is the word root, and there is no double or triple bond, hence it is ANE, butane. Okay, look at the chart. I told you while discussing the chart, we have discussed that OH, this is alcohol function group. If there is only one functional group, means only OH is present, that will come as a secondary prefix. Secondary prefix for alcohol is OL. Okay, all, hence it is all. Okay, so here we have to remove this will be butanol. Okay, where this all is attached, where this alcohol is attached, so it is 2-butanol. Either or we have to write it like but as a word root, but and means there is no double bonds, only single bonds. Where the OL is attached, add carbon number 2, hence this will be butan-2-ol. Both are correct. 2-butanol or butan-2-ol, both are correct. So the meaning of this is there is a 4 carbon atoms, there is all single bonds, there is no double and triple bond, and OL means alcohol functional group, means OH functional group is attached to second carbon atom. Okay, 23. This is another alcoholic functional compound. See, there are 3 OH groups are attached to this one, another here, another here. So count the number of carbon atoms for word root. So 1, 2, 3 and 4. 4 means this will be butane, ANE for this one. Okay, count the number of hydroxy means alcoholic functional groups. 1, 2, 3. So the name will be, here you have to remove this and you have to add OL. So final name will be butane. Where the 3 hydroxy groups are attached, 1, 2 and 3, triol. Okay, butane, but means word root, there are 4 carbon atoms in the ring, in the compound. AN is for there is a only single bonds are there, and 1 at carbon number 1, carbon number 2, carbon number 3, there are 3 OL alcoholic functional groups are attached. Okay, hence the name will be butan 1, 2, 3 triol. Okay, this is ether type of molecule. Okay, look at the chart. These are always come under primary prefix, whether there is alkoxy, nitro, these halogens or these alkyl groups, these are always come in the prefix side. Okay, so in an example here we have alkoxy groups, means ether type of groups. See here, this is alkoxy group, so this will be, name will be alkoxy, means here you have the CS3, methoxy it is. This will be, name of this molecule is methoxy, other will be methane, methoxymethane. The name of the molecule methoxy, the functional group methoxymethane. Okay, look at the next carbon atom, next example. Here this is CH2 ethyl group, CH2CH3, it is CH2CH2CH3. Name of this is also alkoxy group of type of molecule, hence alkoxy comes as a prefix. Okay, This is 1, 2, 3. This is propane. Prop is the word root. Prop is the word root. No double bond, triple bond. Hence it is propane. So for this group, it is ethoxy. It is ethoxypropane. Okay. Next, this is the next functional group. This is aldehyde functional group. This is aldehyde functional group. This is aldehyde. Use the number 1, 2, 3. You have to count this carbon also. Okay, you have to give the number to this carbon also. 1, 2, 3. So this will be, word root will be prop. There is no double bond, triple bond. This is propane. Okay, the for aldehyde group, the suffix will be Al. Okay, for aldehyde the suffix will be L, hence it is A. We have to, here we have A, hence we have to remove this E. So the name will be propanol. Al is for aldehyde. Okay, here again we have to give the number. This is ketone function group. For ketone we will get the ONE as the suffix. Use the number 1, 2, 3 and 4. There are 4 carbon atoms, hence it is bute. No double and triple bond between the carbon atoms, hence it is ANE. The carbonyl group is attached, or ketone function group is attached at carbon number 2, is there at carbon number 2, hence it is 2ONE. Here we have O, hence we have to remove this. Name will be butane 2-one, or else we can also write it as 2-butanone. Both are correct. Butanone means there are, bute means there are 4 carbon atoms. A means there is no double and triple bond. Second carbon, to this second carbon atom there is a ketone function group is present, hence it is 2-butanone or butane 2-one. Okay, next the acidic functional group, that is carboxylic functional group. This will be oic acid. The suffix will be the oic acid. Do the numbering to the carbon atoms. This is carbon number 1, carbon number 2. 2 carbon atoms means it will be ethane. Correct? Eth. There is no double and triple bond between carbons, and it is N. But at first carbon atoms we have carboxylic group, hence it is oic acid. Oic acid is the suffix for the carboxylic group, hence it is, you have to remove this E. Name will be ethanoic acid. This will be the name for this this is ethanoic name for IUP. This is the IUPAC name. IUPAC name means IUPAC name. Common name is acetic acid. Acetic acid is the common name for ethanoic acid. Okay, I give the number to this carbon atom, this molecule. Count the number of carbon atoms. Give the numbering 1, 2, 3 and 4. 4 means it is butane oic acid, because there is a carboxylic group, butanoic acid. Okay, butanoic acid is the name for this compound. 1, 2, 3, 4. There are 4 carbon atoms, hence it is bute. There is no double bond, triple bond. An oic acid means hence there is the presence of carboxylic group. Hence the name of this molecule is butanoic acid. Example 30. This is ester function group, COOR. This is COOR is the ester functional group. Here in the place of R we have methyl group. Okay, when you have this type of molecule, the suffix will be O8. Ester functional group. For look at the chart. This is oic acid. We have done this. Here we can see that COOR type of molecules, secondary suffix will be O8. OATE. O8 will be the secondary suffix for the ester type of molecules. Count the number of carbon atoms. 1, 2. We should not count this. Okay, this is R type molecule. We should not take this. You should not give the number to this carbon atoms. It is not connected to carbon atom. Hence, you should not give number to this carbon atom. Hence, only there are 2 carbon atoms. It is eth. Okay, there is no double and triple bond between this carbon. Hence, it is ethane. Okay, ester functional group attached. So it is ethanoate. Which ethanoate? Now we have to take this in as the prefix. This is methyl ethanoate. Means this is the ester type of molecule. Hence there are 2 carbon atoms are there. Okay, see this. So ethane. Eth is for word root. There are 2 carbon atoms. En is there is no double and triple bond. OAte because there is a ester type of molecule. Ester molecule is there. Which ester? Methyl ester. Means methyl ethanoate. Okay. See here. We should not give the number to this carbon atom. You have to start with from here 2, 3 and 4. 4 means but. No double and triple bond. Butane type, alkane type of molecule. Butane. There is a ester functional group butanoate. Which butanoate? Methyl butanoate. Okay, methyl 1, 2, 3, 4 butanoate. Methyl butanoate is the name for this compound. Okay. 32. Look at the chart. For NH2, when we have the NH2 functional group, this is amine functional group. The secondary suffix will be amine. Okay. Okay, you have to give the number to the carbon atoms. Carbon number 1 and carbon number 2. Okay, this is ethane, and here we have amine function. For amine, secondary suffix will be amine. Here you have A, here we have A. Because of that, we have to remove this E. You have to remove this E in the naming. Ethanamine. Name will be ethanamine. Okay. This. There is no connection between this carbon. There is no bond between this carbon and this carbon. So that it is not ethane. It is methane. Here methane, another methane is attached to N. Okay. Hence the name is, consider this first. Okay. First write the word root. Here we have to count the only this carbon atom or this either of this one. Count this carbon atom. This is only one carbon atom. When you have the only one carbon atoms, the name the word root will be meth. Correct. Only one carbon atoms, hence it is meth. Amine group attached to methane. Methane, E is removed, so amine will be added. Methanamine. Okay, methanamine is the word root, and this is prefix, suffix, and this is functional group, that is secondary suffix. Got it? This is word root. Because we have to consider only one carbon atom, because this is not attached to this one. En is the primary suffix. This is, there is no double and triple bond, and amine is secondary suffix. But this methyl group is attached to N, hence we have to add prefix as N-methyl. So the name will be N will be italic, N-methyl methanamine. N-methyl methanamine means methyl amine is there. If there is a NH2, we should not add this N-methyl. So this methyl group is attached to NH. So that we have to add methyl n-methyl methanamine. Okay. Look at the other type of examples. Here you can see that here you can see the alcoholic function group is also there, and also you have alkene, means double bond. Double bond is also considered as functional group. Okay, when you have the two functional groups, okay, when you have two or more functional groups, in that case we have to name the compounds on the preference wise. So either, out of the when you have the two or more functional groups, we have to select the one functional group as a principal function group and the other is the side function group. One we have to select as a principal function group. So there is a order of preference is there. Look at the chart. This is the order of preference. When you have the COH with this CN, we have to give this will be your principal function group, so that this will be comes as secondary suffix. Like that, this is the order of preference. COH is the having highest higher order, then SO3H, then ester, then acid chloride COCl, then amide CONH2, CN, aldehyde COOH NH2, double bond and triple bond. Okay, when you have these type of when you have two or more functional groups, this is the order of preference. One which having the which is in the higher order, that will be your principal function group, and that comes as a secondary suffix. Then the other will be the primary prefix. Okay, look in this, here we have OH and alkene. Look at the table. Here we have OH and alkene, which having the higher preference. OH is the, here the OH will be the OH is having higher preference, hence OH will be principal functional group, and this will be the lowest principal function. This is not the principal functional group, this is the principal functional group. Hence the name will be, first count the number of carbon atoms, so that this will be your principal functional group. Principal functional group. Hence we have to start numbering from this carbon atoms. This is 1, 2 and 3. Okay, so there are 3 carbon atoms, so there will be prop because there are 3 carbon atoms, and here we can find the alkene type of molecule. Where we have find the alkene, at second carbon atoms you have find the alkene, so alkene is ENE, correct. And we have OH alcoholic function group, that will be suffix will be all, well. Okay, hence the name will be prop 2 enol. Propane is the gives the number of carbon atoms. At carbon number 2 there is a double bond, and at carbon number 1 we have the functional group. It is not necessary to give the number to this one, because we know that this is a principal function groups, hence it is attached to carbon number 1. Okay, or you can also this is enough, but you can also write it like, if you want you can also write it like 2 in 1 all. Meaning of this is OH functional group is attached to carbon number 1. Okay, here also you can find that there are aldehyde functional group is also present, and this double bond is also present. Give the number 1, 2, 3 and 4. This will be your principal functional group. Okay, there are 4 carbon atoms, hence but, where you have the double bond, at second bond you have double bond. For aldehydic functional group we have, here we have to write E, but here you have A, hence I have removed it E. Okay, L. Okay, at 4th carbon atom we have this phenyl group, hence the prefix will be 4-phenyl butene. Okay, name will be 4-phenyl but 2 not OL, it is AL. Okay. Count the number of carbon atoms for the word root 1, 2, 3, 4. Write the word root but. Okay. Then primary suffix will be ENE because there is a double bond. Where we have the ENE at second carbon we have ENE, and one first carbon atom we have functional groups all. It is not necessary to write the one here. If you want to write you can write, but it is not necessary to write. Here we had ENE. Because of the presence of AL, here removed ENE, E here, just EN and EL. And here this phenyl is always present as a suffix, primary suffix, hence this is attached to fourth carbon atoms, and it is 4-phenyl but 2-ene all. Okay. Next, this is the next example. Count the number of carbon atoms. Here these are nitrile cyanide groups, nitrile groups. Count the number of carbon atoms. To this also we have to give the number 1, 2, 3, 4, 5 and 6. Okay, there are 6 carbon atoms, hence the name will be hex. Hex is the word root. There is no other substituents, hence there will be no prefixes present. There is no cyclic group, there is no methyl, ethyl and phenyl groups are attached, no halogens are attached, no nitrogen, hence there is no prefix. Hex is the word root. There the alkene is present at third carbon atom, ENE. Okay, and there are this CN for CN we have nitrile as the suffix, hence nitriles are attached at carbon number 1 and carbon number 6, 1, 6. There are 2 nitriles, hence it is dinitrile. Hence the name of this molecule will be hex 3-ene 1,6 dinitrile. Okay, this is the name for this molecule. Okay, this is also example simple one. This is ketone type of molecules, hence it is the suffix will be ONE. Give the number of number to carbon atoms. Carbon number 1, 2, 3, 4, 5 and 6. 6 means hex, no double entry pronoun, hex ENE. But the ketones are present at carbon number 2 and carbon number 4, hence it is 2, 4. There are 2 ones are present, hence it is dione. Hex is the word root. ENE is a shows that there is a single bond, and there are 2 ketone groups are present, hence we have ONE as a suffix at carbon number 2 and carbon number 4, hence hexane 2,4 dione. Okay, this is an important example. Here you can see that here we have 2 functional groups. One is ketone functional group, another one is alcoholic functional group. Just look at the table. See, ketone functional group and this is alcoholic functional group. Ketone functional group having higher preference than the alcoholic functional group, hence this will be your principal functional group than this one. Okay, when this will be your principal functional group, this will be the secondary suffix. When this is not the principal functional group, this will come as a primary prefix. For OH as a alcohol is a primary prefix. When the OH is as the when the OH is not a principal functional group, this we have to take it in the primary prefix as hydroxy. Hydroxy is the primary prefix for the alcoholic functional groups when it is present with the higher order functional groups in the compound. Here we have 2 functional groups. Carbonyl means ketone functional group and alcoholic functional group. This is higher functional groups, so that this will be principal functional group, and so that this will be your suffix, this will be your suffix, and this will be your prefix. Prefix for OH functional group, prefix will be hydroxy, and for CO suffix will be ONE. This we have know from the chart. Okay, give the number of to the carbon atoms. So this will, however, this will be principal function group, so that this has to get the lowest possible number. 1, 2, 3. There are 3 carbon atoms, hence it is 4, 5, 6. This is 7. Okay, 7 means okay, 7 means hept, no double and triple bond. Okay, no double and triple bond, hence it is EAN. E will be there, but we have to take later we have to remove that E, so that I have taken E only AN. Hept is the word root primary suffix. Secondary suffix, that will be for the principal function group, that is 2, 1. This is secondary suffix. Here we have the primary prefix as hydroxy. Hydroxy is attached at 7th carbon atom, hence it is 7-hydroxy. This will be a primary prefix. Okay, hence the name will be 7-hydroxy heptane 2-one. Okay, there will be a 7 carbon atoms are there, and there is no double and triple, only the single bonds. And at the carbon number 2 we have ketone functional group, and carbon number 7 we have hydroxy functional group. Okay, the meaning of this, hence the name of the structure is 7-hydroxy heptane 2-one. Okay, next one is BrCH2CH double bond CH2. Here we have 2 functional groups, this double bond and this Br. Okay, Br always come as the prefix, as we have discussed earlier. Br is always comes as the prefix. Okay, so this is the alkenes having higher frequency than the Br, hence we have to give the number 1 to this carbon, 2 to this, and 3 to this, because alkene is having higher frequency than the Br. Okay, hence we have to give the number 1 to this, not to this carbon atom. Okay, hence the name will be, there are write the word root is prop, word root is prop, double bond is attached one at carbon number 1, carbon number 1. Okay, and then Br is attached at carbon number 3, 3 bromo. Okay, hence then full name will be IUPAC name will be 3 bromo prop 1 in. Okay, 3 bromo prop 1 in. 1 we have to number 1 we have to give to this carbon rather than this, because this alkene is higher preferred than this Br, hence you have to start giving number to this carbon from this carbon terms. This will be the prefix 3 bromo propane, there are 3 carbon terms, prop 1 in. Okay, okay, the 40th example. Here also we have 2 functional groups, COH functional groups, carboxylic functional group, and the ketonic functional group, that is carbonyl functional group. So look at the chart, so that this will be your principal functional group, so that this will be your suffix. When you have this carbonyl as a suffix, as a prefix, look at the chart, this will be not written. Okay, when this carbonyl is present in addition to the principal functional group, so that this will be the primary prefix, and the primary prefix for this C double bond is oxo. Okay, so that This is the principal function, hence we have to give the number 1 to this carbon atom, 2 to this, 3, 4, 5 and 6. Okay, hence the number of carbon atom word root will be hex. Okay, hex, no double and triple bond, AN, here I will write the detail, AN means alkane type of molecule. This will be oic acid, but this is not taken in the suffix because this is not the principal functional group. This will be the prefix, hence this 5 for ketone functional group. This will be oxo is the prefix, hence it is 5 oxo. Okay, this will be a prefix, that is primary prefix, word root, primary suffix, and this is secondary suffix. Okay, hence the name will be 5-oxo hexanoic acid, or also you can write the number 1, 5-oxo hexan 1-oic acid. It is not necessary to write, but you can also write, both are correct. 5-oxo hexan 1-oic acid means oic acid is present at 1 first carbon atoms. Okay, here in this example we have double bonds, 2 double bonds, also we have triple bonds. Okay, in this case also we have to look for at the chart. Here you can see that double bond is higher prepared than the triple bond, hence the double bond is higher prepared than the triple bond. You have to give the number from, you have to start numbering from this carbon, 2, 3, 4, 5 and 6. Okay, 6 carbon atoms, hence word root is hex. Higher preference means in means double bond, in means ins are attached at 1 and third carbon atoms, diene, and at fifth carbon atoms we have YNE. Okay, hence the name will be hex 1,3 diene 5-ine. Okay, hex for word root, 1,3 we have diene at 1,3 and 5 triple bond at fifth carbon atoms. Okay, this is also the compound containing 2 functional groups, aldehyde functional group and the alcoholic functional group. Aldehyde functional group is the principal functional group which is higher prepared than the alcohol, hence we have to start numbering from this carbon to 1, 2, 3, 4, 5, 6 and 7 carbon atoms. So this will be your prefix, as we are discussing the earlier example. This will be your prefix because this is principal functional group. This will be the prefix. For alcohol, when it is in the prefix, we have to take the prefix as hydroxy. Hydroxy group is attached at 6th carbon atom, hence it is 6-hydroxy. Okay, this is your prefix, 6-hydroxy. I will write as a separate one, 6-hydroxy prefix. Then the word root is hept because there are 7 carbon atoms, hept. There is no double and triple bond, it is ANE. You have to write ANE. Then the aldehyde is attached at carbon number 1, hence Al is the suffix for aldehyde, Al. Okay, so now name will be 6-hydroxy heptane 1-ol. Okay, 6-hydroxy heptanol. Okay. These are the cyclic compounds. See, this is cyclohexane. There's cyclohexane it is. Okay, when there is no substituent, when there is no double bond, cyclohexane. Here we have 1 double bond, it is cyclohexene. Okay, here we have NO2. Okay, how we have to give the number to the carbon atoms, whether we have to start from here or we have to start from here. We know that it should get the lowest possible number. From here we also we can get 1 3, here also we can get 1 3, but to which carbon atom we have to give number 1. Again we have to look at the chart, nitro group and ENE. We cannot find the nitro group in the suffix here. This is a preference chart. Here you can find the ENE, but nitro is always comes as a prefix. Hence the alkene is more prepared, means the double bond is more prepared than the nitro groups. Hence the alkene, for a double bond you have to give the number 1 than the NO2. Alkene is more prepared than the NO2. Hence you have to start the number from this carbon to this one. Okay, we know that the nitro groups are always comes as a prefix, not as a suffix. Hence the nitro is attached at third carbon atoms, hence 3 nitro. Okay, there is no other prefixes. And write the word root. Word root is here, this is okay, I'll write 3 nitro, and here we have cyclic group, cyclic structure, hence cyclo will be added as secondary prefix. Okay, then word root is hex. Okay, there is a double bond at one carbon, hexene. Okay, then you can see that this is primary prefix, this is secondary prefix, this is word root, this is primary suffix, there is no secondary suffix. Okay, hence the name will be 3-nitro cyclohexene. Okay, 3-nitro cyclohexene will be the, you can write 1 or there is no necessary to write also. Okay, if you want to write you can write, otherwise it is not necessary to write 1. Then name will be 3-nitro cyclohexene or 3-nitro cyclohexene. Okay, look at the next example. Here also same, but in place of NO2 here we have OH. Again you have to look for the preference, whether the OH group is more prepared or the alkene is more prepared. Having the more preference. Okay, you can see that OH is more prepared than the alkene. When we look at the chart, you can see OH is more prepared than the alkene, hence OH will be the principal functional group. So the principal functional group should get the lowest possible number. 1 is to this carbon, 2 and 3. Okay, hence 1 2 and 3. So here we have selected this as a principal functional group, hence this will not be the prefix, this will be the suffix. Okay, hence cyclo is the secondary suffix, cyclohex. Ene is attached at 2 carbon, hence it is necessary to write the 2-ene. Okay, and OH is attached at carbon number 1, hence it is OL. Okay, the name is cyclohex 2-ene 1-ol. Okay, this is name for this compound. Because OH is more prepared, hence we have selected this as a principal function group. This will be the suffix, secondary suffix. Cyclo is the secondary prefix, hex is the word root, ene at number 2, at number 2 carbon atoms it is primary suffix. Okay, hence the name is cyclohex 2-ene 1-ol. Okay, in the next example, earlier we have discussed the cyclohexene type of molecules where we didn't have functional group. Okay, but here in this example we have functional group where we have only the methyl or ethyl groups. In those cases we have given the numbering based on the the alphabets, okay, or the numbering system. Here when we have the functional groups in attached to the cyclohexane type of molecules, these carbons should get the lowest possible number. But this the principal functional group attached to the carbon atom, that carbon atom has to get the lowest number. Okay, here this will be your number 1, okay, and this is 2 and this is 3. This is the lowest possible number. We should not give the numbering on this route 1 2 3 4 5. This will be 1 5, but it should get the lowest possible number, hence we have to select this route 1 2 3. Okay, here you can see that there are 2 methyl groups attached to this carbon, hence the prefix will be 3 3 dimethyl. Okay, OH is principal functional group, so that it should not be the prefix, this will be the suffix. So these methyl groups are always come as a prefixes, not the suffixes. Okay, hence the name will be 3 dimethyl cyclohexane. We can write 1-ol or also you can write hexanol. Okay, if you want, you can write hexane 1-ol. It is not necessary to write 1, but this is also correct. 3 dimethyl cyclohexane 1-ol or 3 dimethyl cyclohexanol. Okay, look at this. Here also, this is also functional group. When you didn't have functional group, then we have to choose the number one from either from this or this. But here when you have the functional group, you have to give number to this carbon as a 1. This is 2 and this is 3. Okay, here all the 3 are same, hence it is 1 3 3 trimethyl. 1 3 3 trimethyl. I will write here cyclohexane. Ene is attached to 1 carbon atom, hence it is ene. Okay, this is principal function. The name will be 1 3 3 trimethyl cyclohexane. Okay, this will be the name for this molecule. Look at this. Here you can see that we are attached with chloro, bromo and OH and also methyl groups. We know that halogens are always come as prefixes, not the suffixes. Hence here we have to select this as this alcoholic functional group as a principal functional group, so that we have to start numbering from these carbon atoms. Okay, when you start from this carbon atom, you can give 1 2 3. This can also get the 3. Okay, this can also get the 3. This can also get the 3. Which is correct? You can write this is chloro and this is bromo. Okay, in this type of examples, questions, we have to give the number either this. However, this will be this is going to get the number 1 because this is a principal functional group. Okay, then next this should be the lowest possible number, because here again we have to consider the alphabets of this alphabets B and C. B comes first in the alphabets, then C, so that this carbon is going to get the 3rd number and this is going to get the 5th number. Okay, and this cyclohexane 1-ol. Okay, you can write this one. This is methyl group, this is the prefix. So the substituents are bromo, chloro and methyl. Methyl is attached to number 1 carbon atom, 5 chloro and 3 bromo. B comes first, then C, then methyl. Okay, hence the name will be 3 bromo 5 chloro. Okay, 3 bromo 5-chloro, 1-methyl, cyclohexane, 1-ol. Okay. Look at the next example. Here you can see that 1, 2, 3, 4. Okay, there are 4 carbon atoms in the ring. You can give number from this carbon also you can give, and here from this also you can give the number. Substituent bromo is attached to this carbon atom, so that we have to start numbering from this carbon atom. 1, 2, 3 and 4. Okay, so odd root is 1, 2, 3, 4. 4 current carbon atoms, hence it is but. At second carbon atom we have ene, but-2-ene. Okay, and bromo is the prefix always, hence bromo is attached to carbon number 1, hence it is 1-bromo, but-2-ene. Okay, sometimes in the options they will give you E and Z options, whether it is E or Z, E 1-bromo but-2-ene or Z 1-bromo but-2-ene, like that. E and Z, that depends on this. You are going to study in the isomerism or stereochemistry chapter. When the higher priority groups, here you can see that this is a double bond. Okay, when this is a higher priority group, the hydrogens are called as lowest priority groups, and when these higher priority groups are opposite, okay, this is a double bond. When these are opposite to this double bond, then that will be E. Okay, when these priority groups means when these hydrogens are opposite, then the name will be E. When these are on the same side, like when you have, okay, if the structure will be like this, if the structure is this, here you can see that these are the higher priority group, these on the same side of this double bond, hence then that will be Z. In that case the name will be Z. Here in this case the higher priority groups or the hydrogens lower priority groups are opposite to each other, then that will be E, hence this will be E 1-bromo but-2-ene. Okay, here you have the aldehyde, here you have nitro group. Nitro always the prefix, and also you have carbonyl group, ketone group, and here you can see that this is the higher priority group, hence you have to give, this will be the principal functional groups, hence you have to start giving number from this side: 1, 2, 3, 4, 5, 6 and 7. Okay, this is the longest possible chain. Okay, here you can see that there are 2 methyl groups attached to this second and fourth carbon atoms, hence here you can write 2,4-dimethyl. This is one of the substituent, and this is a nitro, this is attached to carbon number 6 nitro, and the this one the oxo group means a ketone group is attached to carbon number 3, hence 3-oxo. Okay, and word root will be 7, means hept. At fourth carbon atom we have double bond, hence it is 4-ene. And at carbon number 1 we have Al, hence remove this E and add 1 Al. Okay, so M comes first, then N, then O, hence it is name will be 2,4-dimethyl. Here you have to consider M, not D. Okay, di of D. Here we should not consider while writing in the alphabetical order. 2,4-dimethyl 6-nitro 3-oxo hept 4-ene one all. It is Al, not OL. Okay, Al is for aldehyde. Name will be, hence the word root is heptane. Write the carbon. Okay, write the. Okay, here only we'll study how to write the structure from the name. Here you can see that first you have to look at for this word root. It is hept. Okay, write the hept. Hept means 1 2 3 4 5 6 7, means 7 carbon atoms. Hence fourth carbon atom you have in 1 2 3 4. Fourth you have double bond, and 1 carbon atom you have aldehyde group. You can write the aldehyde group, and 2 4 dimethyl. 1 2 at 2 and at 4th you have 2 methyl groups. At 6 carbon atoms you have 1 nitro group, and at 3rd carbon atom 1 2 3 you have carbonyl group. Look at the structure, both are same. Okay, this is the upward structure, just you have written like this, but like this we have to write the structure from the name. Okay, first you have to look at the word root. Okay, you have to draw the carbon number of carbon atoms. Look at the number of carbon atoms. You have to draw the main open chain, and then 4 in 1 2 3 4. Fourth carbon atom you have double bond. At first carbon atom you have aldehyde group, and look at then write the prefixes. 2 4 dimethyl, 1 2 2 4 dimethyl, 6 nitro, 3 oxo. Okay, both are same. Okay, this is the cyclopentane structure. To this the carboxylic group is attached, and methyl group is attached, and bromo group is attached. Okay, so that this will be your principal functional group. And methyl, as we know, methyl and bromo are always add to the prefix, are always the prefixes. Okay, so you have to give the number to the carbon atoms from here. You have to start giving the number from here, not to this carbon atom. It is not the open chain structure, it is a cyclic structure. Hence you have to give number to the carbon atom which it is involved in the cyclic structure. Okay, so you have to start, this is 1. Okay, again you should consider that the substituents get the lowest possible number. When you go from this side, 2 3 and 5, 3 and 4, 1 2 3 3 and 5, it is going to get 3 and 5. But when you give number from this side, it is 2 4 2 4. Hence it is 2 methyl, one of the substituent, and it is 4 bromo. Correct? Okay, write the word root. Word root will be pent. Secondary suffix, you know the cyclic structure is this, hence it is secondary prefix is cyclopent. At carbon number 1 you have oic acid. So you have to add the suffix pentan 1 oic acid. Okay, then just add these prefixes. So bromo comes first, then M, hence it is name will be 4 bromo 2 methyl. These are prefixes, and then secondary prefix is cyclo. Pent is the word root, N is primary suffix, and secondary suffix is 1 oic acid. Hence the name is 4 bromo 2 methyl cyclopentan 1 oic acid. Okay. See, look at the next example. Here you have carboxylic group and also aldehyde group. When you look at the chart, the carboxylic group is the higher priority than the aldehyde, so that you have to start numbering from this carbon atom. 1 2 3 4 5 and 6. Okay, this one we should involve in the chain, not this one, because it is the functional group. Okay, look at the number of carbon atoms. 1 2 3 4 5 6, hence it is hex Okay, and there are two methyl groups are attached at 2 and 5, hence the prefix will be for this methyl will be here I'll write 2 comma 5 dimethyl is for this one, and this one there is a double bond, hence at 3 in, and the secondary suffix is oic acid, is 1 oic acid. Okay, then this one should be the prefix, not the suffix, because this is principal functional group, this is principal functional group, hence the other functional should be the prefix. Okay, hence for the aldehyde the prefix should is formyl, 6-formyl should be the prefix. Hence, okay, write the word root now. Hex is the word root, 3 in is the primary suffix. Okay, then 1 oic acid is the secondary suffix. Okay, this part is over. Then we shall look for the prefixes. Here we have 6-formyl, and at second carbon and fifth carbon atom we have methyl groups, hence it is 2,5-dimethyl. So F comes first, then M. Okay, hence it is the name will be 6-formyl 2,5-dimethyl hex 3 in oic acid or 3 in 1 oic acid. Okay, 6-formyl 2,5-dimethyl hex 3 in oic acid, 1 oic acid. Okay, this is the name of this structure. Okay, the next is this is the benzene ring attached with nitro group, chloro group, and methyl group. In this type of examples, the substituent should get the lowest numbers. Okay, when you start giving number from this side, this is the benzene containing compound, hence the base compound is base name will be the benzene. Okay, and when you start giving a number from this carbon terms 1, 2, 3 and 1, 4, 1, 3, 4, this will be when you give number from this side 1, 3 and 4. Okay, and when you start numbering from this side 1, 3 and 6, this is also not correct, and on this way 1, 2 and 5, this is also not correct. When you start giving number from this carbon atom 3, this is the lowest possible number. Lowest possible number. And while writing the this substituents, that will be in the alphabetical order. Okay, hence means chloro comes first, then methyl, then nitro, hence the name will be 2-chloro, and the name will be 2-chloro, 1-methyl, 4-nitrobenzene. And then you have to start numbering from this carbon atom 1, 2, 3, 4, because this will be 1, 2 and 4. Substituent will be is getting the lowest numbers, that is 1, 2 and 4, and nitrobenzene is your base compound, so 2-chloro, because C, M, then N. Okay, hence this will be substituent should be in the alphabetical order, hence we have selected the prefix as 2-chloro, 1-methyl and 4-nitrobenzene. Okay, next example, you can see that only one substituent is there, that is methyl group attached to benzene ring, hence it is IUPAC name is methyl benzene. Okay, what is the common name for this? Common name is toluene. Toluene is the common name for this molecule. Okay, this is the next example. Here you can see that methoxy group is attached to benzene ring, hence the name is methoxy benzene is the IUPAC name. And what is the common name? Common name is anisole. Anisole is the common name. Okay, then the next example, this is amine group is attached to benzene ring, hence it is aminobenzene. Okay, amine group is attached to benzene, hence this is aminobenzene. Common name is aniline. Okay, this is nitro group is attached to benzene. In this example we have seen that this is the nitrobenzene. Okay, same here, this is the nitrobenzene. Okay, we shall solve some more problems. This is bromobenzene. Now bromo group is attached to benzene, hence it is bromobenzene. Here you can see that there are two bromo groups are attached, hence we have to give the number. This is 1,2-dibromobenzene. It is 1,2-dibromobenzene. Means the two bromo groups are attached at 1 and 2 position. As we have discussed in the earlier example, there are the three substituents, means nitro, there are two nitro and one chloro is attached to benzene ring. In this we have to select the base compound, and the base compound you have to write it in alphabetical order, and the numbering should get the substituent should get the lowest possible number. When you start giving from this is going to get the 1, 3 and 4, but when you give numbering from this side, this is 1, 2 and 4. Hence we have to give the number from this one. This will be the 1, this is 2 and this is 3 and this is 4. But here you can see that there are two nitro groups are attached to 2 and 4, hence it will be 2,4-dinitro. Okay, and chloro is attached to carbon number 1 chloro. Look at the this alphabetical order, C and N, so that this will be substituent. The name will be 1-chloro 2,4-dinitrobenzene. Okay, this one you have to write in alphabetical order. While giving the numbering, the numbering should be in the lowest possible number. Hence we have given chlorine to this carbon 1, this is 2, 3 and 4, hence it is 1-chloro 2,4-dinitrobenzene. Okay, the next one here also same, you have to give number from this side, 1, 2, 3 and 4. Okay, write the substituents. This is 2-chloro and this is 1-methyl, this is 4-nitro. Okay, 2-chloro. Just first you have to look at the benzene ring. There are three substituents. Okay, methyl, chloro and nitro. Just give the number. The numbering should get the lowest possible number, 1, 2, 4, and write the substituent 2-chloro, 1-methyl and 4-nitro. Then look for C, M and N. The name of prefixes should be, means the first we have to start with 2-chloro, then 1-methyl, 4-nitrobenzene. Okay, 2-chloro, 1-methyl, 4-nitrobenzene. C comes first, then M, then N. Hence it is 2-chloro, 1-methyl, 4-nitrobenzene. Okay. Okay. Here also same. There are three substituents. Number 1, 2 and 3. Here you can use the common names. Sometimes you can also use the common names. Hence write the substituent 2-chloro, 3-methyl, and you can write 1 methoxy, or also you can directly take this as the base compound. Hence you can write the name like 2 chloro 3 methyl anisole. Okay, sorry, not 3, it is 4. It is not 3, it is 4. 2 chloro 4 methyl anisole. Anisole means this is the anisole. To this anisole, add second carbon atom. When you have selected the base compound, the methoxy group is attached to number 1. Means this carbon is, and it should be understood that the carbon atom which is attached to this methoxy group is number 1. So this is the next example. Here you can see that the benzene ring attached to amine, CS3 and ethyl groups. So here you can take this group as the base compound, means aniline as the, you know that when the next group is attached to benzene, this is the aniline, and here you can take the aniline as the base compound. The methyl group is attached at carbon number 2 and ethyl group is attached to carbon number 4. Hence you can start with, here you can look at the M and E. Here you have to start with ethyl. Okay, the name will be 4-ethyl 2-methyl aniline. Okay, aniline is the base compound, hence the methyl group is attached to carbon number 2 and ethyl group is attached to carbon number 4. Hence it is 4-ethyl 2-methyl aniline. The next one is okay. We know that the OH, when the OH group is attached to benzene ring, this is called as phenol, right? When the OH group is attached to benzene ring, this is called as phenol. So that you have to take this as a base compound, and you have to start numbering from this carbon atom 1, 2, 3, 4. You should not start not take the numbering from this side, because it is going to get the 4 and 5. So that you have to start 1, 2, 3 and 4. So the substance attached to 3 and 4 dimethyl, correct? These two methyl groups are attached to carbon number 3 and carbon number 4. Hence the name will be 3,4 dimethyl phenol. Okay, 3,4 dimethyl phenol. Okay. Here you can see that this is the benzene ring attached to this one. So here we can take this benzene group as the substituent. Okay, you can take this as the phenyl ring as the substituent. Hence you have to start this one we shall take as the word for the word root, as the open chain structure. The phenyl ring is attached to this carbon atom. These two bromo are attached to this carbon atoms. Hence you have to start numbering from this carbon atom 3, 4 and 5. 5 means word root will be pent. There is no double and triple bond, hence it is pentane. There is no suffix, and as we know, bromo halogens are always the prefixes, and phenyl ring is also the prefixes. It is phenyl ring is attached to carbon number, hence it is 1-phenyl. Okay, bromo are attached to 2 and 3, 2,3 dibromo. Okay, hence the name will be, B comes first, hence name will be 2,3 dibromo 1-phenyl pentane, correct? Phenyl is also substituent. It is attached to carbon number 1. 2 bromo groups are all attached to second and third carbon atom. The main chain is pent. There is no double and triple, hence it is N. Okay, here we can take this as the word root. This is the base compound. We know that nitrobenzene is the word root, hence start numbering from this carbon atom. So this nitrobenzene will be your word root, but you have to give the number from which gets the lowest possible number. Hence you have to start when you start from this one, either you have to take from this side or you have to take from this side. This is going to get 1 2 3 1 3 and 6. 1 2 3 4 5 6 1 3 6. And when you start from this side, 1 2 and 5, 1 3 5. But when you start grouping from this carbon term, it is 1 2 3 4. So 1 2 4. Okay, which is the lowest possible number? This will be lowest possible number. This is not the lowest possible number. Hence, you have to give number to this carbon 1, to this 2, and this is 4. Okay, hence the name will be, here the substituents, write the substituents first. 4 ethyl, 1 fluoro, and nitrobenzene is at 2 nitrobenzene. Nitro group is attached to the second carbon atom. Hence, E comes first, and the name will be 4 ethyl, 1 fluoro, 2 nitrobenzene. Okay, name will be 4 ethyl, 1 fluoro, 2 nitrobenzene. Okay.